All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 53, you should be just about done. Make sure you're off those cell phones. My goodness. AirPods, put them away. And give you a little bit more time, and then we'll get a Nearpod going so we can see what you did for the warm-up. All right, here goes the correct answer on your screen. It looks about right. Maybe the number one could be like switched, but it looks about right. Double check your work. Hands if you got something like that. Okay, good. All right. You good over there, Anthony? All right. All right, copy the agenda, please. Warm-up number 53, transforming functions. Tonight's home plate, only one problem. Again. You're like, what? Only one? Oh, yeah. We're getting there little by little. So therefore, which reminds me, last night you did only one problem for transformations. So just because I'm nice, I'm giving you 400 points for this one. So go to Canvas, turn that in. 400. 400. Let's go. Turn that in. Only one problem. That's all you needed to do. One problem. 400. Ah. So that was the problem. Should be on your screen. For tonight, I'm not going to give you a code for Nearpod, so you're going to have to go to YouTube to watch this video lesson that I'm recording here. Got that, Anthony D? Yes? All right, so YouTube, go watch this video. And the next problem, which is that one, is it on your screen? Yep, that's tonight's home plate. All right. And then get a Cornell note ready. You do need a Cornell note. No Freyer model, just a Cornell note. Our objective for today, I can transform a function using different parameters. I can transform a function using different parameters. Copy that. All right, here we go. I can transform a function using different parameters. I can transform a function using different parameters. So we've been on transformation of functions. Hopefully it's been a smooth transition. Yes? Yes, Mr. Q, give us more home plate. All right, good. And we know what functions are by now. Parameters are, we said, are numbers that transform a function to another function. We went from Y form to function notation. We did these. We said that was parameter K that moves it up and down. From there we went to these. And then we went to these right here. And then we said that these are parameter H that moves it side by side. And we got to this portion, and you wrote the general rule. Is that correct? So do me a favor on your Cornell note, write it again. But this time, I want you to copy a table underneath that rule. And it looks like this. Copy that table on your Cornell notes. So you're going to write the general rule, g of x equals f of x minus h plus k. And then the instructions are predict what will happen by completing the table. And then sign for h. Positive, positive, negative, negative. Sign for k, positive, negative, positive, negative. And what would happen in regards to transformation? I'll give you some time. Copy that. All right, just a reminder for today's home play. Tell you where you're going to go to get the home play. Bah. Where are we going, Rebecca? YouTube, yes. Go watch the video lesson. And I'm recording it right now, so probably Rebecca's going to hear herself in there. All right, here we go. So, look up to the screen. Guys, look up to the screen. So it says, our general rule to get a new function g of x, we have f of x minus h. H moves it from side to side, is that correct? And k moves it what? Up and down, right? So, right now, we're going to go to Desmos to do a little activity, which is on the next slide. And on your paper, you're going to fill in here, look up to the screen on each row and write what happens to the function as you move levers and so on and so forth. So for example, I'm going to give you a function, and then it's going to, whenever you move the h, which means in here, if it's a positive value, what does it do to the function? And then when it's a negative value, what does it do to the function, and so on and so forth. Same thing with k. So when we get to the last, I'll tell you which slide. So with that said, let me move you to the next one. So at this point on your screen, log into that activity, please. If you want to do Desmos or Google, it's up to you. Do that right now, please. You should have this, yes? And it reads, this is the original quadratic function, aka parent function. Tell your neighbor what aka stands for. What does aka stand for, Martin? Also known as, yes. So from this point forward, anytime that we start with a function, Anthony, whenever we start with a function, that is going to be called a what? A parent function. In this case, here's a function, f of x on the left side equals to what? X squared. Does that look familiar? Yes, Mr. Q, is my home plate. Yes, that was last night's home plate. That is correct. And did it look like that? Yes, except for, if you notice, I'm going to zoom out and it continues going and going and going. It doesn't stop because the arrows indicate that it keeps going, but I'm going to leave it about right there. All right, next. Go to the next slide, please. At the top, go to next. And it reads, move the lever under the parameter k to see the transformation. What does k do to the original function? Just keep it to yourself, move it around, and look at the values change for k, and look at the graph as you're moving it. All right, talk to your neighbor, let them know what you noticed. What did you notice when you moved it? Make sure they agree with you. All right, we got a yes. All right, so you moved it either to a positive value, yes. You moved it to a negative value, yes. How about moving it to 0? Change k to 0, move it to 0, see what happens. Tell your neighbor what happens when it's 0. What happens when it's 0, Martin? What's that? Oh, you're trying to get to 0? Okay. It's like the same as what we started with. Yes, that is correct. All right, go to the next slide. Click next. Then it says, move the lever under the parameter h to see what the transformation. What does h do to the original function? Again, observe what happens to the values of h as they change. Tell your neighbor exactly what you saw, please, just to make sure they got it. So now, on your last slide, combining it with this table, it says here, move the h to a positive value. Look up to the screen. Move the h to a positive value, k to a positive value. How does that transform your new function? Write it out right here in words. Talk it over to your neighbor. Make sure they agree before you write it out. Start filling in your table. All right, I'll give you guys some time. Go. All right, looks like Biani's got it so far. Danelli looks like she's got it as well. Very good. Who else got it? Selena's got it. All right, Selena, let's go. Courtney Jean, I see you. Emily P, got you. Marley, you all right over there? Yes. All right. Martin, of course, got it. Let's go. All right. Well, let's start with Anthony D. What you write for the first row when you substitute, look up to the screen, guys, for those of you that are having some doubts. So here we're going to substitute a positive value into our general rule here and a positive value for k. What's going to happen to the function, Anthony D? You said up and to the right. And have you got that? That is correct. So k, since k is a positive, it's going to move up, positive. And h positive is going to the right. That is correct. Now, some of you might be saying, Mr. Q, but didn't you say if it was positive, it went to the left? It's going to change this to a positive to go to the left when we substitute a negative value because there's already a negative in there, okay? So far so good. So, make sure you have that. So put here k positive and h positive, just to make sure that you got that. All right. Show your neighbor the next row, and then we're going to have Anthony pass it to someone. Next row. For the next one, h is positive and k is negative. All right, Anthony, pass someone. Clarissa, where's the function going to move? Down and to the right. And have you got that? That is correct. So this one is k is negative. And we got h positive. Okay. Next, show your neighbor the next row. Next row, what happens to the function? And then Clarissa's going to pass it to someone. All right, Clarissa, pass someone? Me? Let's go. I'm going to do a pass on this one. And let me pick someone. How about Kimberly? What's going to happen to the function? It goes up and the left. Hands if you got that. That is correct, because K is a positive, and H is a negative. Yes. So far, so good. And last but not least, tell your neighbor what to write on the last one, and Kimberly's going to pass it to someone. Last one. Negative and negative. All right. All right, Kimberly, pass someone. Courtney Jean, go. Down to the left. Hands if you got that. That is correct. So this one is down, so K is a negative to the left. H is a negative. That is correct. All right. So from 1 to 5, how comfortable are you with that so far? Okay, we got it. All right. So now that we know what each of these components do, let's go to the next slide. Not that one. Send me your notes. I want to see what you did. All right, let's go to our graph paper. Get your graph paper in front of you, the big one, And copy that problem at the top left, copy that. It's my life. All right, so once again, example MJQ. Let's go. Graph the function f of x equals x cubed. That goes at the top left of your graph paper, and on the left, leave a little bit of space like here. Leave an empty space, and then copy these transformations. First one in green, red, blue, and black. We're going to do this one together. All right, guys, once again, reminder, as we approach our Thanksgiving break, when we come back, we're going to continue with a lot of graphing. So make sure you have all your materials. We're going to need 4 different colored pens. Once again, my bread and butter are black, blue, red, and green. Those are the 4 different colors I'm going to continue using. Also, you need at least 1 or 2 highlighters. Also, you're going to need some graphing paper of your own, that the Quadricule, I think it's called. I think I've seen them at the Dollar Tree. Here there's a plug for Keys Bargain right there by the gas station. So make sure you get all materials. You're like, Mr. Q, but then you're going to have to start washing cars or clean the house. I don't know, giving foot massages or something. Let's go. All right, here we go. It says graph the function. Remind your neighbor, what values are we going to use for x? What values do we use for x when they don't give us any? All right, Jacob, go. -2, -1, 0, 1, and 2. Let's go. All right. So here we go. Let's fill in f of x. So this one now is cubed. Students, cubic functions, students. So let's see. -2 cubed. What does that mean, Mr. Q? It means -2 times -2 times -2. So what is negative times a negative? Positive times a negative? Negative. Okay. What is 2 times 2? 4 times 2? 8. Fill that in. Next value, negative 1 cubed. Tell your neighbor what to write here. Negative 1 cubed. What do we write there? Then we'll have Brandon enlighten us. Negative 1 cubed. What do we write there, Brandon, Felix? Negative 1 is correct. Write that in there. Let's go. Everyone, 0 cubed is 0. 1 cubed is 1 times 1 times 1, which is 1. And 2 cubed is 2 times 2 times 2, which is 8. Let's plot that. Negative 2, negative 8. Negative 1, negative 1. 0, 0. 1, 1. 2, 8. You're like, what? Oh yeah, this looks cool. Or maybe it's just the AC kicking it. Let's go. Woo-wee. All right, so let's go from left to right. Start down here. Connect to that next point. Go through the point of origin to the other point. Through that last point. And arrows at the end. Arrows at the end. And we're going to label this what? F of x. All right. There it is. So, with that said, looking at it, change colors. Tell your neighbor what's going to happen to these 5 points according to this green transformation. Tell your neighbor, please. What's going to happen to that? All right, sketch it to see where it goes. In green, go. All right, help us out. Good conversations, I heard. Help us out, Brianna. What do we do? So all the points are going in which direction? Up. That is correct. 2 steps. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. And that one is g of x. And if you got that, so far so good. All right. Let's go to the blue one. Look at the blue one. Tell your neighbor what's going to happen to the original f of x according to this blue transformation. Tell your neighbor, please, what's going to happen to that original f of x according to that blue one. Don't depend on my mama. Stay focused. All right. Tell us what's going to happen in regards to this blue transformation. Pass someone, Brianna. Let's go. And I'm going to do a hard pass on this one. And let's get Rylan. What's going to happen to this original one according to the blue? To the right, 6 steps. So therefore, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we label that g of x. All right. So Let's go to the other black one, this one, the last one on, I mean, we're not done, but the last one on these 4. Tell your neighbor what to do to the original to get this transformation, please. And then from there, tell them what to do with the red one. What to do with the red one as well. I'm going to send you a screen so you can send me what you did on your graph. And we'll stop at that point. Your home play is basically what we just did, extra practice. Good thing you guys are doing all your home play, right? You're not copying from people. All right, good. Woo-wee. All right, once again, just a reminder, as you're submitting your graphs, tell your neighbor where to go for tonight's home play. Yeah, somebody asked me, who asked me? Somebody. Make sure you go to YouTube, please. It should be in there. Bye. All right? Those of you following on YouTube, make sure you do extra practice on your own. Have a good one. Bye.